Try that again. Welcome back, chemistry fans. All right, here is the solution to the Unit 10 exam. And these are going to be let's start with the multiple choice. Okay, so let me jump into this real quick here, share my screen. And then I will get the questions up and working. Here we go. Number 1, let me make it bigger so you can see it. Try this again. Maybe it will work. Oh my gosh. Why is it doing this now as I'm trying to do it? Okay, here we go. So I have a stoichiometry problem in the scope of a multiple choice. So we've got 12.25 grams of potassium chlorate. You may be asking yourself, which one is potassium chlorate? Anything that ends with ATE is a polyatomic that would have 3 elements. This is your one. So here's where we start. Generally speaking, those values are always on the reactant side of the equation as well. We are looking for grams of oxygen. Okay. So this is straightforward. This is grams to grams. There is nothing tricky. There's no limiting reactants or anything like that. So let's just set up a ratio 12.25 over 2 times the weight of all of this. Potassium weighs 39, chlorine weighs 35.5, and there are 3 oxygens that each weigh 16. So that is 48 plus 35.5 plus 39, that's 122.5. The X is over 3 times the oxygens. Each of the oxygens, again, are 16. Now we cross multiply. So I've got 112.25 times 3 times 32 divided by 2 divided by 122.5. And I get 4.8 as my value. So let's see which one of those comes as close as possible to that. Let me get rid of my face off of here so I can actually see what I'm looking for. And there is a value right there of 4.8, which gets you the answer. Okay, so let's jump to number 2 then. So on number 2, it's another stoichiometry problem, but this time we've got different units. So this time, same reaction, same starting material, 12.25 grams, but it's asking us how many liters of oxygen. So we've already set up our value, 122.5 was the weight over here, times 2. This time, though, we're doing the X over 3 times 22.4. So it should make this a little easier that if you added up your weights the first time, it gets simple with how we're solving it the second time. Divided by 2, divided by 122.5, and you should get 3.36 liters. And that's that first value right here. Is what I've got as my correct answer. Okay. Enough of that. Let's go into number 3, and it will actually be a whole new problem finally. Okay, so what is the coefficient for water when the following equation is balanced? Okay, so let's balance it. So what we need to understand is that the water gets split into H and OH. So if I have that, I would have 2 of those. If you can see that, it makes it so much easier because now there's just 1 Ba, 1 SO4. Your answer is 2. Very simple to balance, hopefully. Use limiting reactants. Oh no, we've got starting materials of 0.5 of this and 1.4 of this. So let's find out how many moles of excess reactant there are. So there's several steps in this process. Well, I guess I kind of gave it away here, didn't I, with these? So I need to probably change those, and I will get rid of those on the test so that it doesn't give it away. So I've got 0.5 over 2 equals, and we'll just do the carbon dioxide because it's easier. I don't know why it's easier. It just seems that way. And then I would have a second one of 1.4 over 7 equals X over 4. So they're both going to be the same. So if I cross multiply here, 0.5 times 4 divided by 2, I get 1. No. 0.5 times 4, that's 2. That's equal to 1. All right, and then 1.4 times 4 divided by 7 is 0.8. So my limiting reactant should have been the oxygen. I'm not sure why. Oh, that is correct. Okay, so that's my limit. So that means that this is the excess. So that's why all those answers right now are in C2H6. So what I'm going to do next is I got to figure out how much of that excess there is. So I have 0.8 moles of O2. So that's where I start, 0.8 over the 4, because it starts the same way. So it's right here. And this time I'm going to go to the excess. So I am going to say Y, I don't know what it is, divided by 2. So I've got 0.8 times 2 divided by 4, and that gives me 0.4 is what was used of the C2H6. But I was given a total of 0.5. So if I subtract those two values, that's where the 0.1 comes from, which is my answer up here. Okay, so I got to remember to go fix that. Number 4, C2H6. I got to get rid of that so that you won't sneakily know which it is. And we get rid of that. We're moving on to question number 5. And on question 5, we have a reaction. It says that sodium carbonate and hydrochloric acid are produce sodium chloride and carbon dioxide and water. Sodium carbonate and hydrochloric acid producing sodium chloride, carbon dioxide, and water. What type of reaction is this one? So this should be a decomposition. It's breaking apart and it's making more pieces. So it has 2 on one side, it has 3 on the next. So that one's a little bit more difficult for you to see. Hopefully, though, that would not have thrown you too much and that you won't think that it's always going to be a single replacement, double replacement in that scenario. Aluminum reacts with oxygen to form aluminum oxide. Which of the reactants below is correct and properly balanced? So we got to figure out how many of the aluminums and how many oxygens need to be on both sides. Well, if I've got these combining together over here on the right side, I'm going to have to make sure that those charges crisscross Al2O3. Well, they're all Al2O3s. That is correct. So to make it work out over here on the right side, though, the oxygens are always found in nature as O2s. Well, that would not balance over here with my oxygen. So by default, this is my correct answer down here. That's the only one where I have enough oxygens on both sides, even without trying to balance it. All right, number 7. Substances are dissolved in water. Which ones are dissolved in water? They are the ones that have the aqueous. So that would be this answer right here. And then if we go to number 8, what is the mole ratio between oxygen and carbon dioxide? Well, there's an unwritten 1 there, so it's a 1:2 ratio. And then number 9, almost done. Which of the following is true about the total number of reactants and the total number of products? Okay, so the mole ratio here, I've got a 1 and an 8. That means that there are 9 total moles of reactants. Those are not atoms, those are not liters, those are not grams. So the only part here is this is correct. All right, so you had to know what a coefficient is actually measuring. And the percent yield formula. Percent yield is the actual divided by theoretical. That's lab value divided by stoic value. So which is not true? The actual yield may be different from the theoretical yield. Well, they have to be different. They do not always go to completion. Yes, they do. The actual yield may be different from the theoretical yield because insufficient limiting reactant was used. Well, that's not true. The percent yield the actual yield may be different from the theoretical because insufficient limiting reactant. All right. The percent yield is the ratio of the actual to the theoretical. That is correct. That one is guaranteed to be correct. The value of the actual yield must be given in order for the percent yield to be calculated. That is correct. So it's got to be one of these two that I have messed up on here that we need to reread. The actual yield may be different from the theoretical yield because reactions do not always go to completion. That is also correct. That's the whole purpose of a yield. So it's this one here where insufficient limiting reactant. Well, that's the very definition of a limiting reactant. So the actual yield may be different from the theoretical, not because of the limiting reactant. The limiting reactant doesn't have anything to do with it. So that is your choice there, B. All right, this takes care of everything that I wish to share with you today about your multiple choice. I will get the free response up and running here in just a second. Thank you. Bye-bye.